Hey everyone, we're going to use the sum and difference formulas to write the given trig expression as an algebraic expression containing u and v. So basically what we need is, this has the form of cosine of alpha plus beta. So we're going to use this formula here. So as you can see, we need a cosine of alpha, cosine of beta, sine of alpha, sine of beta. And what we're given is tangent. So we're going to also use this Pythagorean identity to help us find cosine and sine, and this one as well. So set alpha, let alpha equal inverse tan of u. So tan of alpha equals u. Similarly for the beta, we have beta equal inverse tan of v. So tan of beta equals v. Now that really doesn't help us much because we need cosine and sine. So that's where I'm going to use and by the way, this is restricted from both of these, negative pi to pi, negative pi over 2 to pi over 2. Quadrants 4 and 1. So I have a tan here, and I know secant secant squared equals 1 divided by cosine squared. So I'm going to find secant. So I have secant squared of theta equals tan squared of theta plus 1. So if we want to use alpha, I'm going to change these to alpha. All right, and I want just secant, not secant squared. So I'm going to square root both sides. If I square root both sides, this square over here goes away. So I'm just going to take it away. All right, so this is going to equal, I know that tan is u, tan of alpha, so this is going to be square root of u squared plus 1. That means cosine of alpha is 1 divided by square root of u squared plus 1. Now the same thing's going to happen for v, all right, for our beta angle. So if you do the same thing, we'll get cosine of beta equals 1 divided by square root of v squared plus 1. You're just doing the same procedure, but instead of alpha, we're using beta. So we have our cosine of alpha and cosine of beta. We need sine of alpha and sine of beta. We're going to use this identity here and know that sine squared of alpha equals square root, or 1 minus cosine squared of alpha. Again, if you square root both sides, is square root here, and I can take away the square. So now all I have to do is write this as square root of 1 minus of 1 divided by square root of u squared plus 1. Okay, we're going to simplify this. And this is going to give us u squared plus 1 minus 1, I'm just getting the common denominator, divided by u squared plus 1. Now when you take the square root of this, these go away, so square root of u squared is just u divided by square root of u squared plus 1. So that's your sine of alpha. All right, and your sine of beta is going to be the same thing. you're going to do the same thing but change these to betas. And so sine of beta is going to be your v part. V divided by square root of v squared plus 1. Now all we have to do is use our formula and write this all out. So just make sure you have all this written down. We have our cosine of alpha, sine of alpha. So we need this, write this down. And then we need this one. And this one is sine of beta. And that's this one. All right, so let's use our formula. And we're going to have cosine of alpha plus beta equals cosine of alpha cosine of beta minus sine of alpha sine of beta. And now we're just substituting. So this equals 1 divided by square root of u squared plus 1 times 1 divided by square root of v squared plus 1. Then we have minus u for this one divided by square root of u squared plus 1 times v divided by v squared plus 1. And then just to simplify, these two are the same. So the common denominator as u squared plus 1 times square root of v squared plus 1. 1 times 1 is 1 minus u times v is uv. And this would be your final answer. Thank you. Have a nice day. Bye-bye.